Now, if your tissue has not been previously fixed in aldehydes, we need to get that accomplished. In order to do that, it takes about 2 hours, and you want to be sure that you spend that time because the primary fixation is particularly important. This is currently done in Karnofsky's fixative, which is a combination of glutaraldehyde and paraformaldehyde, and I have that in phosphate buffer. So when our primary fixation is almost complete, it's time to get ready for our next step, which is the buffer wash before osmium tetroxide. In this wash, we want to use the same buffer as we used as the vehicle for the fixative. I'm currently using phosphate buffer, but you may be using cacodylate buffer. Just remember that with cacodylate buffer, it does contain arsenic and you're not going to be able to dispose of that down the drain. So keep that in mind, and you will need a separate container for arsenic waste. So in the buffer, I like to use large volumes. I always use a pipette when getting rid of aldehyde, osmium tetroxide, and resin. I don't like to pour that. I have my separate waste container for that, and then I have my waste container for aldehyde and osmium and things like that in a separate box to keep any vapors that might emanate from the material. Even though you can't read this, this is my aldehyde waste, and now we can see that that's what that is. And after my fixation of 2 hours in the primary fix, I'm going to get rid of the primary fixative in the waste container. And then when I wash with these, I want to be sure to use copious volumes because we want to get rid of any residual aldehydes that may be contained in the tissue. And then if you can get your bottle open, which is difficult when it doesn't have much of a mass to it, I'm going to again use the pipette because I don't want to pour any aldehyde or osmium or resin and get it on the outside of the vial, so that way then my hands stay clear. Speaking of hands, you can see that we have our gloves on, we're in the fume hood, and we have goggles, so we're taking all the safety precautions that we need. When we get down to the very bottom of the vial, I don't want to suck any tissue up, so what I do is I put my pipette flush to the bottom and then tilt it towards the pipette, and that way then the tissues remain in the vial and I don't have to worry about trying to get them out of a pipette if I suck them up and something always seemed to stick a little bit. I always give them a little shake just to resuspend the materials and then put them on the rotator. It's always a good idea to have some type of agitation so that the samples are continually introduced to new fluids. So after 10 minutes of our first rinse, I'm now going to utilize the waste container that's going to be able to dump down the drain. This will contain phosphate buffer, my water rinse after the second osmium rinse, and then also my ethanol from dehydration. At this point I use the pour, and the way I do it, I put the lip right on the edge and start a nice simple pour. I'm not dumping, and if I pour it gently, then the tissue stays in the bottom. Now if you are using lung or leaf plant material that has a buoyancy to it, you won't be able to do that until you get to maybe the ethanol stage. But with kidneys and more dense tissues, livers, you don't have to worry too much if you pour gently. So again, we're going to do 3 rinses in buffer at 10 minutes each. So after our rinses, it's now time for osmium tetroxide, which is a heavy metal stain and adds amplitude contrast to our tissues. We have to remember that the vapors of osmium tetroxide are also of a fixative nature, and so you do have to be careful. That's why I store them in a container so that we don't get any osmium vapors in the fume hood while it might not be turned on. We always want to be sure to wrap our osmium after we are done with it in parafilm, and that way then that keeps any potential vapors that might come out of the seal out of the box. Now we can see that this bottle, the container, is well sealed in that the parafilm was not stained at all with the osmium. I'm using 4% aqueous osmium. Sometimes people use 2%, some people buffer their osmium, and you always want to label your bottles so that in case someone's not aware of the hazards that osmium has, that they're a little bit cautious. People shouldn't be doing this if they don't know what's going on. So after our final 10-minute rinse, I'm going to discard the rinse, buffer rinse in my waste container, and I use a glass pipette when pipetting osmium tetroxide. Sometimes people will use a plastic transfer pipette, and that's just fine. There's no big deal. I just prefer the glass, and that glass is easier to rinse out after the residual osmium tetroxide. When I do this, remember that you don't need large volumes of osmium, really just enough to cover the tissue. A couple mLs is just fine, and even after the osmium, 2 hours in that step, you'll notice that the solution itself is still clear, indicating that there is still osmium that's reactive. So of course then make sure that you want to put it in the proper waste container, but that you don't need large volumes of osmium. It is expensive, and you can see that they're already starting to turn dark. Again, since the vapors are bad, we want to be sure to close that up right away. And we're agitating again. We always want to make sure our solutions are exposed with the tissues. So about 2 hours, osmium has a very slow penetration rate of about 1/2 millimeter per hour. So we want to be sure that our tissue is well fixed. We want to be sure that our osmium tetroxide is well sealed afterwards. The bottle itself should have a good tight seal, but then to ensure that we don't have any vapors coming out into the containers that are housing the osmium, that we don't get any residual osmium powder. You'll notice it as a black material on containers. Now, my box has tinted windows in it, so that is not, the brownish is not due to osmium tetroxide vapors that have fixed it. It was a tinted box to begin with, just to keep things straight. And after my osmium, my next step is going to be waste osmium, and I'm just going to get that out right now, even though it's 2 hours before I'm going to need it. Again, get the materials out there you're going to utilize and put everything else away. That way you don't make mistakes. So after the 2 hours in the osmium tetroxide, our saturated vats should be well fixed and have a nice heavy metal stain to them, which helps the membranes look good. At this stage, we can see that I'm going to take out the residual osmium, and that is the solution is still quite clear, which indicates that there's still reactive osmium tetroxide. I have a little bit of corn oil in my bottle, and what that does is when we add the reactive osmium to it, then it does reduce and form metallic osmium. Also at this stage, I'm putting my pipette flat to the bottom so I don't suck any tissues up, and I have a piece of parafilm there to have my pipette on. I'm going to use DI water. Some people used to use a buffer, but I prefer DI water, and it works just fine. Again, large volumes for our washes. Like we did with our buffer, the DI water is just fine for dumping down the drain. We're going to get rid of our osmium waste container, and then proceed on. We're going to do 3 different changes. Now, the one thing I do with osmium is that after the very first rinse from osmium straight, is that I like to dispose of that in the waste container as well, because sometimes you will find that even the waste, your first rinse of waste, has a little bit of osmium material in it, and we don't want to dump that down the drain. So I usually dispose of my first rinse after osmium into the waste container, and then from now on I'll be able to dispose of that waste down the drain. I like to use the parafoam down there. It's a good material. It keeps my any resins and osmium, things like that, off of your work bench, so you don't have contamination there. When we're done with the osmium waste container, again, the best thing to do is keep things clean. Put it in a container that is out of the way, so you don't make mistakes and utilize the wrong material or put it in the wrong bottle. And get ready for your next step. After our washes, we will be getting ready to do dehydration. So we're going to do 3 washes. We did the 1 wash that the residual wash went into the osmium bottle, and now I can again just pour it out, and carefully, slowly at first, and that way the tissue remains in the bottom and we don't have to worry about dumping out tissue. And again, if you have more buoyant tissue, then that doesn't really work, and then you have to use a pipette. If I were to pipette this out, I would use the plastic transfer pipettes that you can see in the background there. After our water rinses, going from the osmium tetroxide, again we want to make sure that we get rid of any residual materials. We're now ready to do dehydration. Many people use ethanol, some people will use acetone, some people transition from ethanol to acetone. Whatever your SOP does, that's a good thing to do. We start off with lower concentrations. Again, I'm using 50%, some people use 25%. And I'm going to dump the waste into the same container that can be dumped down the drain. So this is the DI water from my last rinse after osmium tetroxide. I pour it slowly. We're still in an aqueous environment, so buoyant tissues could still float. And now I'm going to go to the 50%. When we're into the ethanol, even the buoyant materials will be able to sink to the bottom, and you'll be able to pour off without having to use a pipette. So that's one convenience that it goes with. Right now, I'm going to recap that, put the 50% out, and get the next material out. I want to be sure that I don't have too many of these bottles out, so I might make a mistake and put 100% in after dehydration, after water, or vice versa, and that would be distressful to the tissues. Again, just pour out slowly. It's nice, and it's a lot faster, especially when you have multiple samples, to be able to pour than it is to pipette. Also, that tends to allow you to put more volume in, which is better for transfer, so we don't have as much carryover from one solution to the next. Always take care of housekeeping. Get rid of what you just used and put out what you're going to use next, so you don't get confused. That's one of the biggest challenges of new lab people, is that they just have too many things out, and you can use the wrong material at the wrong time. So just be careful. We don't need really large volumes. We just want to make sure that there's a good transition from one fluid to the next, from one concentration to the next. It's not a big deal, and just be careful. These again are for about 10 minutes each. We want to be sure that the water gets out of our tissue, because epoxy resins, which are our normal resin, which we're going to use in the near future, is not particularly miscible with water, and it will not polymerize in the presence of water. And you can use your left hand, even if you are right-handed, for doing your transitions. I just happen to use my left hand there and right in front of the video. Now, when we're dealing with the 90% and then the 100%, we have to be careful that we have the solution that we're going to be using next readily available, because before, when we were using our aqueous environments, we didn't have to worry about the tissue drying out. But here, since our solutions are much more volatile, if we're not ready for the next solution, like being able to get the top off of our bottle, then the tissue, after I poured it out, if I were to have trouble getting the material out or forgot to get it ready, it would be possible for that tissue to dry out. And once the tissue is dried out, it's done, and there's not anything that you're going to be able to do to get it back. The resin will not infiltrate into a dried out tissue. So with this, I'm going to do 2 changes of our 100% with utilizing the squirt bottle. And after that, I'm going to use glass distilled alcohol from a bottle. And what that is to make sure that there was no hydroscopic effects of water being absorbed by the ethanol, that it might not be 100%. And so here, I want to be sure that I'm going to get all the water out, so I'm going to use a fresh bottle of ethanol. While our final dehydration is going on, I'm going to go ahead and prepare my resin. I'm using the epoxy resin Embed 812, and I do this gravimetrically in a disposable beaker. It is nice, you really can't use pipettes because of the viscosity of the resin. I used a bottle of some acetone on my Kim wipe to always wipe off the threads of a bottle, so that we can always be sure to get the cap off. If you've ever done that, you'll understand. So I'm making up 40 mLs, and so, or 40 grams. So at this stage, I'm going to put in 20 grams of my Embed 812, which is the primary resin, and I'll be then adding 10 mLs of NMA and 10 mLs of DDSA for a proper ratio of my resin. Again, a little bit of acetone, and I don't want to get acetone into the material. I want to just wipe off the threads so it's easy to get the cap off. And get that out of the way and get to my next one. And so then this is the DDSA. The DDSA will, higher percentage of DDSA will increase the hardness of my resin. And you can see it looks like someone didn't wipe the threads off easily last time, so that's why I want to make sure that I do it. Since I'm making, again, 40 mLs, I'm just going to use 10 grams of this. The ratios, whether it's grams or mLs, is difficult. The only thing is using a pipette, the viscosity, you can't get it all out of a pipette, so you have to do it by weight. There is a WPE, weight per epoxide, that makes that a little bit more accurate, but really I just do the ratios of volumes to weight. Now here's the NMA, and that then is the third part of my resin before I put in the accelerator. And you can see I have 30.1 grams. I almost made it perfectly. A little bit here or there, if it's 29 or 31, is not going to make that big of a difference in your block. You just really need it to be respective ratios. Again, clean off the top. It looks like that top is a little bit dirty. And so again, that just makes sure that you can get the top off. Have been bottles in different labs that I've been in, and you have to use a nut cracker to or a pair of pliers to try to get the top off. And in one case, the bottle actually broke before the top came loose. Now, before I add the accelerator, I want to mix this up, and as I mix it up, I want to make sure I don't see any stir lines in there and get a good mix. I am using DMP30, and this has a 2% or 2.5% of my total, so I made up 40 grams, and so I'm going to put in about 0.8 to 0.9 grams of my DMP30. If you use BDMA or DMAE, they have different concentrations, so always read the instruction sheet that came with your individual resin. The final concentration of your accelerator is extremely important. If you put in too much, the block can be hard and also cause uneven polymerization. So I used about 0.8 mLs or 8.8 grams of this. As I mix this, we'll know it turns from that light straw color to a more dark amber color. And as I stir this, I'm really just folding it. I'm not beating it. I'm not trying to add a lot of air bubbles to the material. We don't want a lot of air bubbles. In fact, some people will put that in a vacuum to get rid of the excess gas in the material, and that does outgas for quite a while. So that's why I just do a nice more folding versus a beating. I'm putting some ethanol in vials because I'm going to then mix since I'm transitioning from ethanol to resin, I'm going to add a little bit more of my 100% dehydrant, and if that's acetone or propylene oxide, that's just fine, whatever you're using. And then I'm going to add, since I'm doing a 2-to-1 right now, it's 2 parts of dehydrant to 1 part of resin, I'm going to just put in some dehydrant, and then I'm going to add just about half again as much, so that'll be a 2-to-1 ratio of my dehydrant to resin. And again, I use a pipette. I don't want to pour this because it's good to keep things clean. You notice that I haven't spilled a drop during this whole procedure, and I can go through a full embedment procedure with 1 pair of gloves and never get any resin anywhere. And I have seen some things different. If you're not careful, things can get all over the place, and people always think it's okay because I have my gloves on. We give that little swirl around to make sure that we have it into solution, and the first infiltration I do for an hour. Infiltration is a very important step. We have to be able to get that resin down to the very intima. So now I use resin waste. Anything that gets resin on it, I'm going to save and polymerize in the end because it's nasty, it's a little carcinogenic, and can cause skin irritations. And so the best thing to do is just polymerize it in the end. And so anything that comes in contact with resin, pipettes, gloves, always get polymerized in the oven after the fact. And here I'm taking the material out. Again, since the resin is quite thick, we don't have to worry too much about floating, but you want to be sure that you don't get any tissues up into your pipette. So again, just flush to the bottom and tilt it. Since we're working with our resins and things, I'm now going to transition. I was in pure ethanol before, and now I'm transitioning to resin. So now I can add the resin, and then I'll add an equal volume of my dehydrant to give me a 1-to-1 ratio. Sometimes people will do 3-to-1. I do that when I'm dealing with plant or any hard to infiltrate material. I'll start off with a 3-to-1 ratio, then a 2-to-1, and then a 1-to-1 ratio. Again, I'm using the glass distilled, and notice I didn't use that ethanol that I had poured out before because I don't want it to have absorbed any water from the atmosphere. And I'm gonna just pipette this in. You know, I could pour it in depending on how accurate you want to be. A little bit here or there is not going to make a big difference, you know, with the one-to-one. And there is a fair amount of variability built into this procedure in terms of concentrations and times. So this is just a general basic idea of what to do. We're going to give that a little swirl. And you can do 45 minutes. Some people will even do a half an hour in terms of that second infiltration. And so the times and things are not written in stone, but a little bit longer is never going to hurt unless it's in dehydration of propylene oxide, which can cause a fair amount of extraction of lipids in different tissues and make them pretty dry. So we do want to be careful, but when we're in resin, a little bit of extra time doesn't hurt. So that was our one-to-one, and it is now time to go to 100% resin. And this is important. Again, we need to get this resin infiltrated into the tissue for proper sectioning and support of our tissue. I think I spilled a drop there, of course, just when I say it, I never spill. If you do spill some resin, always be sure to wipe that up with acetone. Acetone is more miscible with the resin than ethanol. And now transitioning, it is a little bit difficult when we're transitioning from our resin. We want to be sure that we don't have any carryover, so I'm going to use a different pipette. Now this is the 100% resin, and it is more viscous. Oh, yeah, I got a little piece of tissue in there. So you do have to be careful. I never pour when I'm dealing with resin, the 2-to-1, 1-to-1 ratios, or the 100% pure. I never pour because it's just too messy and you can get things all over the place. People always say, I have gloves on, I'm okay. The trouble is if you get it on your gloves and then you turn off the fume hood or you touch something else, then you've transferred the resin to other areas. You may be safe, but now someone else that goes to turn on the water suddenly finds resin residue on the handle of the water because you touched it with your glove. So just be careful. So this is our second change of 100%. In a little bit of time, now I'm gonna, some of my materials just got up on the side there. It's okay to work a little slowly and deliberately. Don't think that you need to be all fast and moving things right away. Just take your time and do it properly, and everything is fine, and you can keep things nice and clean. Now some people will just do sometimes a 45-minute, even a 30-minute of the second resin change. I'll do an hour. Again, I tend to do longer infiltrations than are required simply because it's important. While that's going on, I'm getting my materials ready. I have my blocks and labels made. And the easiest way to deal with your tissues now, I just dump them out into a weigh boat. I don't have to worry about them drying out or anything. So I dump them into a weigh boat, which is nice because then it's easy to pick them out. I've taken my my beam capsules, and what I do is I just put one or two drops of resin right into the very bottom of the beam capsule. And this is important. If you put too much resin into the beam capsule, then you're trying to push your tissue down in, because of course we want the tissue at the very tip of our block. We don't want it halfway in between. And if we fill it up with resin and then we try to put our resin in there, my block in there, the tissue in the block, it's difficult. I don't usually use the tops of these. Some people do, and that's fine. I don't find that it's much of a problem. Again, just a couple drops. I try to get it in the very bottom. And then I can just pick out the tissues. I try to have as minimal amount of carryover as possible. So generally what I'll do is just roll the tissue up the side of the weigh boat, and that way then it gets off all of the old resin, and it sticks very nicely to my wooden applicator stick that I've broken, a nice sharp point. And I'm going to then add a piece of tissue, one or two, depending on what your preferences are. Sometimes I'll do 3 pieces. And this way also is a good time that you can separate out. Sometimes as you cut, it's maybe a little bit too big or a little too small, and you can orient your tissue at this stage too if you're doing flat embedment molds or whatever. Again, just put in a couple drops, and then it's easier to move your materials around. When I add a label to my blocks, I have pieces of paper with the number written on it or name, whatever it is, and I hold that in my tweezer and curl it around. Sometimes it's a little bit easier. If you have lower weight paper, like a 15 pound paper versus a 30-pound paper, it's easier to roll, and you don't worry about having it be so problematic. But if I roll it and then release it on the inside of the tissue, it's a little bit of a spring mechanism, and so it stays right at the surface of the tissue. And I want to be sure then when I do add the resin that I don't pour it right over top of the label and have that go down. I want to be sure to fill up all of my beam capsules. I fill them up pretty much to the top, so they're right to the very top. You don't have to worry too much. You don't want to have just a little bit of resin in there. More is better. And once I have those all filled up and I have the labels in it and the tissues, it is now time to put them in the oven. We have a 70-degree oven. Some people do a vacuum oven. This is a vacuum oven, but I don't normally evacuate. And now I'll put those in, and tomorrow morning I'm going to look at them, and they should be all polymerized. Thank you.